Now that we've looked at our functions algebraically, let's look at what we can do graphically with regard to a function. So, what is the graph of a function? And all it is the set of all points that satisfy f of x equals y. So A is our input, b is the output, so f applied to a should equal b. So f of a equals b. So if we look at this blue curve is our function f's graph. It's in the xy plane, and if we look at a value on our x-axis, say a, then we can go up to the blue curve and we can see where it takes us on our y-axis. So the point AB is on the curve f. A is the input, b is the output. So whenever you think about a function and its graph, there are some key features that you can draw from this graph. One is the domain of the function. And if you want to think about the domain of the function, what you can do is you can take your graph and you could smash it to the x-axis. And you're basically looking at its shadow. So if we smash our graph to the x-axis, then what do we get? We get this interval from here to here. And so this interval would be the domain of our function. Likewise, we can do the same thing for our range. So we smash, for our range, our function to the y-axis. So every value, we go from bottom to top actually. Notice some values in our range get doubled up on, or even tripled up on as we go up. Doesn't matter. Our range is simply the interval on our y-axis. So from bottom to top, we would read our values. Likewise, we can look at our x-intercepts and our y-intercepts. So the x-intercepts are where we intersect our x-axis, and our y-intercept is where we intersect our y-axis. So here we have a graph of our function f, and we want to find f of 2. So notice, since we're finding f of 2, 2 is an x value. So we find 2 on the x-axis and we see what the y value is. So find 2 on the x-axis, go to your curve, and what is the corresponding y value? -2. So f of 2 equals -2. What I want you to notice is what point is on the graph because of that. 2, -2. 2, -2 is on the graph of our function. Now, what is the domain of our function? So, take your curve and smash it to the x-axis and see what you get. So pause the video and see how you fare. So if we go left to right, and we smash our curve all toward the x-axis, what do we get? So we start at -7 and we go all the way to 4, and you'll notice we start at -7, we end at 4, and we include them. So we do indeed get -7 to 4, and we include both with brackets. Now let's look at the values of x where f of x equals 3. So the first thing to do is decide something about 3. Is 3 an x value or a y value? Well, it's the output of our function. F is applied to x and the output is 3, so 3 is a y value. So we'll find 3 on the y-axis, and we'll say, how in the world did we get there? What x values got us there? So how do we get to 3? We got there from this point and from this point. So the x value of -4 got us to 3, and the x value of -2 got us to 3. So x equals -4 and -2 are the values that yield 3 as output. Now what's the range? So take your curve and smash it to the y-axis and see what you get. What is the shadow on the y-axis? Remember, whenever you write your answer, write it as interval notation and make sure that you go from bottom to top. So if we smash to the y-axis, we get to -3 and we keep going up. In fact, we get some duplicated values, quite a bit as we go, but that's okay. And so on and so forth. And you'll notice we go from -3 all the way to 4. And we actually include the -3. We were assigned to that value, and we were assigned to the 4. So we have -3 to 4, and we include both. Now, given this graph, what are the x-intercepts? So what are the values where we cross the x-axis? So we cross there, and we cross there. So the x-intercepts are x equals -6 and 0. What are the y-intercepts? Where do we intersect the y-axis? We intersect at y equals 0. Now, where are the values where f of x is less than 0? So we want to know where the output y is less than 0. So let's take a look at this by maybe shading our function there. So where is y less than 0? So we can see that our y values for these points will all be less than 0. Likewise, anything over here. So what are the values of x for which that happens? So notice the values of x are found on the x-axis. So at -6, our y value is equal to 0, but to the left of 6. So between -7 and -7 and -6, our y value is negative. So -7 to -6. What about -7 itself? Is y less than 0 there? Yes. But -6, it's not. Well, where do we start again? At 0. And we go from 0 all the way to 4. We're looking at the x values again. So from 0 to 4. Does 0 itself yield a y value less than 0? No. What about 4? 4 does. So we're looking at these x values yielding a y value less than 0. Now, let's find the number of times where we cross y equals 1. So where does the line y equal 1 even occur? Y equals 1 here, but not only there, anywhere along this horizontal line. So, how many times do we cross that line? We cross there, and we cross there. So, we cross twice. What about the line x equals -1? Well, the line x equals -1, x equals -1 here, but anywhere along this vertical line. So how many times do we cross the vertical line? Only here, so only once. So try to find the domain of this function. Remember, the domain is the set of x values, so you're going to take this and smash it to the x-axis. So if we do that, where would the shadow be? So we would include the -1, but we should not include the 2. So the domain will be -1, 2, 2, but not including the 2. Now let's look at the range. The range, smash everything to the y-axis. We do obtain -2, and we include +2. So our range should be -2 to 2. Now, go ahead and find the x-intercepts. Where does this graph cross the x-axis? In these 3 places. So we're looking at x equals -1/2, +1/2, and then lastly 1/2, which would be 3/2. Now what about y-intercepts? How many y-intercepts are there, and what are they? So where does it cross the y-axis? Only here. So we're looking at the y-intercept of y equals -2.